So you're going to look at what they're actually giving you, okay? So on this first one, they're giving you hydrogen and oxygen. So let's look at oxygen first. What's your valence number, or how many Lewis dot structures do you have for oxygen?
6.
Yep, you have 6. Don't forget you're counting from left to right, right? So you have 1, 2, 3, 4, 5, and 6. 1, 2, 3, 4, 5, and 6. Okay. Now your other one is hydrogen. How many Lewis dot does hydrogen have? It has only 1. Very good. Okay. Now you're going to use what we did yesterday. So is it a covalent bond or is it an ionic bond? Oxygen, is it a metal or non-metal? Non-metal. And hydrogen, is it a non-metal or a metal? Non-metal. So when you have two non-metals together, what are they? It's covalent. Very good. So what does covalent do? Do they transfer or do they share? They share. So now watch this. You see how you have a dot here and you have a dot there? They're going to share. That's your bond. That's when they chemically combine together. Okay? They're sharing electrons. So you're gonna loop around dot to dot. Now the whole point here is one of them's the hydrogen, there's only 1 dot, so it's gonna be sharing with oxygen. So oxygen, instead of having 6, it now has 7 dots, right? Now to be a stable element, how many dots do I need to have to be happy? 8. Very good. So we can put another hydrogen. Now I need more space, so I'm drawing into the other side, okay? And hydrogen has 1 dot. And again, because it's a covalent bond, they're going to share, so you have a loop around both dots. This is your covalent bond, okay? Now look at your notes. What shape does that look like? Look at your notes. What shape does that look like? It looks like bent. So your bent is going to go here. This is where you're going to tell me the shape of your molecule. Okay, we see that? Your first thing is you're going to draw the Lewis dot structure, and then you're going to loop around whether it's shared or if it's transferred. So whenever it's shared, you're going to go from dot to dot, and that's your bond. Whenever it transfers, it's going to go from dot to an empty space, and that's going to be your bond. We'll do an example of that in a minute, okay? Let me show you how you're going to calculate your electron negativity, and that's the one you were asking about, right? So you're going to look at the periodic table, that force it takes to break that bond and pull that electron away from the other one, right? So let's say, for example, let me go ahead and use you for a minute, and give me your hand. If we're playing tug of war, okay, and we're both trying to fight for that space, and he's gonna pull his direction, I'm gonna pull my direction, right? He's definitely stronger than me. Okay, so he's got a larger negativity. He's pulling that way. Okay, that's an unequal pull, so that's a polar bond. Now, if I put the two boys together and they actually try to play tug of war, they probably have about the same amount of strength. That's going to be an equal pull, so that's going to be a non-polar bond, okay? So it's like playing a tug of war. So when we come over here to this side, because I have an unequal pull, it's going to be a polar bond right there, okay? And little easy trick, if you see a 0 here, that means it's going to be non-polar, okay? Unless you have something that's an equal pull, like let's say I had a sulfur and then I had an oxygen and an oxygen, and this number is going to be the same as that number, and so both are going to have an equal pull in either direction, okay? So then that's going to be a non-polar bond, because if I have an equal pull on both sides, is that rope going to move? Is it going to move? No, it's not. So you have an equal force on each side, and that's why it's going to be nonpolar. Okay? I know it sounds opposite, but it is nonpolar. Okay? Let's do an example of, let's do an ionic. To your actual assignment, this page, but I'm going to grade that notebook next week. You can take a picture of the board if you need to for the list. Okay, so you're going to do this to each one of these in here in this handout. You're going to turn it into the cubby. What questions do we have? That's going to go on page 21. Okay, any questions we have? Okay, I'm going to go ahead and post this in case I gave you. We have oxygen over here, and we also have hydrogen. So now oxygen is what? Yes, and my electron negativity is at the bottom, and it's how much? 3.5, and we're going to subtract hydrogen, which is how much? 2.1. So what is that going to give me? Yep, it's going to give me 1.4, and this is going to be my electron negativity. Now that electron negativity is the, so let's go ahead and clear this out, and let's do something else. Pick a metal, or you know what, let's do, pick something in the alkali group. Pick something in group 1. Calcium? No. Potassium, there you go. Potassium. Now, what's my Lewis dot structure for potassium? How many dots do I have? I have 1. Very good. So now let's pick something else, like, let's do fluorine. Fluorine has how many dots? 7. So I have 1, 2, 3, 4, 5. Now I'm going to put it on this side, the dots on this side, so I can leave this side in the empty space. So I'm going to put over here my 6 and then my 7. That way my empty space can be there. Okay? Because the closer it is to your other element, that way you can have an easy bond. All right? So now, is this an ionic bond or is it a covalent bond? K is what? Is it a metal or a non-metal? Potassium is a metal. Very good. Okay, fluorine is what? Fluorine is a non-metal. Very good. So are these going to share or transfer? They're going to transfer. Very good. So that means you're going to go from the dot to the empty space. Instead of going to the dot like we did in the other covalent bond, they're going from the dot to the space. We see that? Okay, who doesn't see that? We good? Okay, and that's your bond. You just have from 1 to 1. So look at your notes. What does that look like? Look in your notes. What shape does that look like? You just have from 1 to 1. Yep, I heard it. Linear. So you're going to have, your shape is going to be linear. And then you're going to look for your electron negativity. So here's my potassium. Here's my fluorine. What's my electron negativity for fluorine? Yep, 4.0. What's my electron negativity for potassium? 0.8. Okay. So when you subtract, what's going to be my answer there? What's my electron negativity? Yep, it's going to be 3.2. So now, is this polar or is it non-polar?
Polar.
Non-polar means they're equal. It's polar because they're not equal, right?
Do we always subtract like that from highest from lowest?
Yes. Yes, good question. Do you always subtract like your highest from the lowest? Yes. Okay, because you're just subtracting within the bond. Okay? Where do we have a question so far? Okay, and so because it's an unequal pool, fluorine obviously has more of a pull, right? It's going this way. So it's going to be polar because it's not equal. You see that? Yes?
Yes.
Okay, so going back, guys, this is going to be on page 21 of your INB notebook. The notes that we just took on the shapes, that's going to be page 20. Okay?